Most AI projects don't fail because the model is wrong. They fail because the model is flying blind. When outputs feel generic, disconnected, or just slightly off, the root cause is almost never the architecture. It's that the model had no real understanding of the specific situation it was responding to. Context is the silent variable that separates AI that sticks from AI that gets quietly abandoned. Imagine two customer support bots running on identical models. One gets a raw query with no background. The other receives the customer's account history, their last 3 interactions, the product version they're running, and your internal escalation playbook. The second bot sounds like a seasoned team member. The first sounds like it was trained on someone else's business. The model didn't change, only the context did. This is one of the most underappreciated levers in all of applied AI. Retrieval augmented generation became popular not because retrieval is some revolutionary breakthrough, but because it gave engineers a repeatable, systematic way to inject relevant context exactly when the model needs it most, at inference time. Before RAG, models were locked into whatever they learned during training. RAG essentially gave models a live, queryable memory. But here's the thing most teams miss. Implementing one retrieval layer and calling it done is like installing a library but only ever reading one shelf. The teams getting real results aren't just asking what documents to retrieve. They're asking 4 distinct questions. What does the model need to know about this specific user? What is the current state of the system or product right now? What domain-specific rules and policies apply in this exact scenario? And critically, what has already been tried and failed? Each of these is a separate context layer, and most production systems are only covering 1 or 2 of them. Building all 4 is what separates a demo from a tool people actually rely on. One of the most powerful and most overlooked forms of context is failure history. When a model knows that 3 previous approaches were already attempted and didn't resolve the issue, it stops retreating the same ground. This mirrors how experienced humans actually work. A senior engineer doesn't suggest the same fix twice because they remember what was ruled out. Building feedback loops and failure logs into your context pipeline is one of the highest leverage, lowest cost improvements most teams never implement. There's a failure mode that's the exact opposite of context starvation, and it's just as damaging: context flooding. Dumping loosely related documents into a large context window doesn't make the model smarter, it makes it distracted. Language models attend to noise and miss the signal buried underneath it. Relevant scoring, filtering, and intentional curation of what goes into the context window matters as much as coverage. Precision in context construction is a skill, and most teams haven't built it yet. Before you upgrade to a larger model, before you redesign your architecture, before you run another round of prompt engineering experiments, ask one question: does this system actually have the context it needs, at the moment it needs it, in a form it can use? That single question will expose more real problems than any leaderboard benchmark ever will. Most teams jump to capability when the real constraint is information. Fixing the context layer is faster, cheaper, and more impactful than almost any other intervention available. The teams that win with AI long-term aren't the ones with the biggest models or the cleverest prompts. They're the ones who treat context as a first-class engineering concern, something designed, maintained, and continuously improved. Your proprietary context, your customer data, your domain rules, your institutional failure history, that's what a generic foundation model can never replicate. Start treating context architecture with the same rigor you bring to your data pipelines, and your AI systems will start feeling like they actually belong to your business.